All right, so as you stated earlier, some of you drew an obtuse triangle, some of you drew an acute triangle, and neither of those two groups was incorrect. What I gave you to work with in the beginning, was an angle, a side, and a side. Those were the three things you couldn't change. This angle, this side length, and this side length. But you could do whatever you wanted to with this angle, and this side. It's because of that exact problem is the reason you can't just blindly go in and use the law of sines on a normal side angle problem. This is called the ambiguous case for the law of sines. Now, let me ask you this. If you were to punch in, let's make up numbers for this. Let's say this angle was 60 degrees. Let's say this one was 8, and this piece was 6. Whoa. 6. If it gave you that, and let's say you could make two triangles there, which triangle do you think it would give you? This one or this one? Obtuse or acute? Which one would it give you? I'll tell you. The law of sines, when you use inverse sine, when you use the inverse sign to find an angle, it will never give you an obtuse angle. Ever. Law of sines, when you use inverse sine to find an angle, will only ever give you an acute angle. So, it would have given you this one. Now, what I'm going to be showing you today is a way to find out if you're dealing with a multiple answer problem. Now, before we get into that, let me ask you this. Let's take a look. Who remembers what these two angles right here? Who remembers what those two angles are called back from geometry? They form a line. There's a pair of them. I just said both the words that they're called. There's a pair of angles that form a line. Take those two words, line and pair, and put them next to each other. Nobody remembers this in geometry? Linear pair. When two angles are right next to each other, they form a linear pair. Now, that's important because one thing you're going to be finding out here very, very soon, and it'll be more obvious to see, is that these two angles, the two angles that differ from the two triangles, are supplementary with each other. That's important because later, when you have to solve for both of these possible solutions, when you punch this into the calculator using law of sines, sine 60 over 6 equals sine of, we'll call it A over 8, it's going to give you the acute angle. And that's one of your solutions. To find the other one, all you're going to have to do is subtract from 180 because they're supplementary. But I think that'll be more clear once we look into how we're going to find those. So, the ambiguous case for the law of sines. You're going to need to make some kind of chart in your notes because there's a list of things you have to do to find out if it's going to be, it is the continuation of 6.1. 6.1 part 2. Okay, so here are your problems. It's going to give you two sides and an angle, and it's going to ask you to first determine whether you're looking at one unique triangle's measurement, potential of two triangles, like the one we just looked at, or you might be looking at things that could even form a triangle. So the first thing you have to do is figure out which of those situations this is. And the first thing you need to do, we'll kind of make a procedure chart for this. Step 1. You need to see, is the angle they're giving you acute or obtuse? Is it acute or obtuse? Because there's going to be 5 possibilities for all these. 3 of them are acute, 2 of them are obtuse. And you have to know which set of criteria you're looking at. Okay. Now remember, this is called the ambiguous case for the law of sines. And you can only use the law of sines when you have a side and an angle pair. So, the angle you'll be looking at, you'll also have that side for it every time. First off, if it is acute, you're going to have 3 possibilities. There's a diagram of this in the book. I don't know why I didn't use it, but whatever. If it's going to be acute, there's 3 possibilities. One of them is no triangle. One of them is 2 solutions. and the other one is one solution. Now, just like before, we're going to start with the one solution. You're going to have some unknown side length. You're going to have a fixed angle measure, a fixed side length, and a second side. Now, here was our imaginary side from the DOM. And we said it could swing up this way, make obtuse, swing up this way, and make acute. What is the shortest distance? This is just like a general thing you hear people say, like when they're just talking. Shortest distance between 2 points is a what? Straight line. If I'm looking for the shortest way to connect this line, this side, to this angle, I'm not going to veer off to the side. The shortest possible way to do it is to form a straight line. Back in geometry, we knew we had a perfectly straight intersection if they formed what kind of angle? Anybody remember? Yes, if they form a right angle. So, here's what you'll be needing to do today. It'll be one solution if this is a perfect right angle. And you will know that by doing this test. We're going to call this angle A, side A, and side B. On all of these, you're going to be given some angle A, some side A, and some side B. That's what you're going to be given every time. Yep. Now, what we're interested in seeing is, if this is a right triangle, from the angle we're given, which two sides are we given to work with? Yeah, I mean like in SOHCAHTOA words. Which two sides are we given to work with? Opposite and hypotenuse, that's right. And sine of A equals A over B. Now you don't have to put this in your chart yet. I'm showing you what you're going to put in your chart. Sine of A equals A over B, which we're only allowed to use in right triangles. But in this particular possibility, it is a right triangle, so we can use it. Now, if we were to solve for side A, what would we do here? Just multiply by B? If this was a perfect right triangle, then A would be perfectly equal to B times sine of angle A. So this part is B equals sine A. Sorry, I wrote that backwards. A equals B times sine A. We talked about it down here, I just wrote it wrong. A equals B times sine of A. And all three of these possibilities are going to be A something, B sine of A. I'll give you a hint. The other two are going to be inequalities. Well, we said this is the shortest possible distance this can be, isn't it? This side A, if it's the perfect length forming one exact right triangle, then you have B sine of A. Then it's going to equal B sine of A. So you'll be given the pieces. So like, for instance, let me show you one of these in, so like let's take number 17. We're given side A, side B, and angle A. It is an acute angle. So remember we said acute or obtuse. These first three that I'm giving you are acute. So this would fall into our first test. And what you would need to do is you're going to need to compare 20 and B times sine of A. If they equal, you know it has one solution because you must be looking at a right triangle. If those two things equal. Now, B sine A represents the shortest possible length that side can be. So, if this is the shortest possible length this thing can be, then what do you think is going to happen if it's not that long? What's going to happen if it's only that long? There's no way it could possibly connect with that base side. It's going to be swinging around, but it's not going to be able to connect and make the triangle. That is the no triangle situation. If A is less than B sine A, or less than the minimum length of that side, then you're not going to have a triangle. And that's going to look like this. And there's no way you could swing this to connect it to this base here. It's just not long enough. Just not long enough. Now, if A is greater than B sine A, then you're looking at your DOM scenario. You're looking at one of these, and that's when you're going to have two solutions. If A is greater than B sine A, you have two possible solutions, and that is like it was in the DOM. You could have two possible triangles. Now, let's think outside the box here for a second. There's one more possibility here. What if side A is freakishly long? Like, yeah, you could swing it over way over here and make that big long triangle, but could you swing it back here and still connect with this base? No. No. So one other possibility for acute angles, if it's acute, I'm going to erase this and put this on a different slide. If it is acute, then the one other possibility is if A is greater than or equal to B, you're automatically looking at one solution. And I'll draw that again, because you'll be looking at something like this. And there's only one way that could possibly swing out and make a triangle. And that's that right there. If it's swung way over there, you could have that one acute triangle. But that's it. If A is greater than or equal to B. Therefore, the top three are if A is less than B. You only use those if A is less than B. Now, again, we're making a chart so that when you do your homework, you'll look for these things just in what they give you. They'll say, oh, it's acute. A is less than B. I know it has to be one of these. It's acute. A is greater than or equal to B. I know it has to be one solution. There are just going to be quick little ways for you to test it. Now let's go back to the one we were looking at, because it has to be one of these. Those are the only acute possibilities. So, is A the side opposite the angle? Now, it won't always be labeled A. I'm looking around. Dang it, these all are. You might have one on a test. They might not be labeled A and B. It might be, in fact, let's just relabel this real quick so you don't get in the habit of just thinking, oh, it's always going to be the letter A and B. It could be little x equals 20, little y equals 15, and big X equals 40 degrees. What you're interested in is the side opposite the angle. That's the one you're putting by itself. So first off, acute or obtuse? So you know it's one of those four possibilities. Is the side opposite our angle the biggest side, or at least tied for being the biggest side? Yes. Little x is bigger than little y, which makes it... too many slides. And I went the wrong direction anyway. Which makes it this possibility. Our side opposite of our angle was bigger than our other side, so I immediately know that it's one solution by that part of the chart. The side opposite my angle was the biggest, so I immediately know it has one solution, and my problem is half done. So let's go back to that slide. Wrong direction. We're going to mark it one solution, and we'll come back and solve it in just a second, because we still have to find what those angles and sides are. We're going to go through all the acute ones and first label them. Number 20, we'll just go straight down. Number 19, acute or obtuse? Acute. Is the side opposite our angle the biggest side? One solution. Because once again, just like this one, it's that bottom scenario. Of those four, it was the bottom. We'll skip 21 for the time being, because we haven't talked about obtuse yet. Number 23, acute or obtuse? Acute. Is our side opposite the angle the biggest side? No. So I have to do, dang it, I keep going, the B sine A test. I need to compare it to B sine of A and see if it's less than, greater than, or equal to. So somebody punch into your calculator while I boot up my calculator, 40 times sine of 30. Please make sure you're in degree mode. Hold on, let me get this out. All right, you said 20? Now, B sine A, what did I say that represented? Anybody remember? How did we word that? B sine A is the shortest possible distance that side can be. And you said it was what, 20? So our side is less than the minimum possible distance, therefore making this one right here. 10 is less than, they found this to be 20, therefore it is no solution. And those are the best ones for you, because it means you have nothing to do to solve it. Because there's nothing to solve. No solution. And that one's done. 25, acute or obtuse? Acute. Is the side opposite our angle the biggest side? No. So I have to do my B sine A test. Somebody type in 18 sine 60. 15.6. So our side is bigger than the minimum possible distance, which made it how many solutions? 2 solutions. And I'll show you how to solve those in just a moment. 2 solutions. Try 27 through 31. Just find if it's no, 1, or 2, and we'll see if we get the same things. You should be punching in B sine A for 27, 29, and 31 and concluding if they are 1 or 2 or no solutions.
You say the side of the opposite angle was bigger or wasn't bigger than the calculation?
If the side opposite our angle is not the bigger side, you have to do that B sine A test. You won't know that it's no solution until you do the B sine A test. Like here, this one was smaller. I did the B sine A test, and we found that this was smaller than B sine A, which made it no solution. That's when you know it's no solution. Yeah. 27, what did we get? 2 solutions? Anybody get something different than that they'd like us to take a look at? I don't know the answers to these, so I'm taking your word for it. So if you got something different, don't think you may be right. No? 29, what did we get? 2 solutions again? 31. No solution. Awesome. So none of these, did they perfectly equal? Well, that's unfortunate. If they perfectly equal, then, that's that right angle scenario, but I guess they didn't give us any of those. Okay, so we've solved all the acute angles to find out if they are 1 solution or 2 solutions. Now, I said, I never really went back to my step chart. Step 1 was seeing if it was acute or obtuse. I guess it's really impossible to list this in steps because then they branch. If it's acute, you then have to see if the side is bigger, then do the angle B sine A test. So it's like 3 possibilities. If it's obtuse, let's think about this for a second. If the angle they give us is obtuse, what must the side opposite that angle be compared to the other side? It has to be the biggest side. The whole law of sines is built around the concept that the bigger the angle, the bigger the side. Is it possible to have 2 obtuse angles in a triangle? No, that would be in excess of 180 degrees. So, the obtuse test is very, very simple. If the side opposite the obtuse angle is the biggest side, it's going to have a solution. It's possible. If it's not the biggest side, there's no triangle. Because it's impossible. Because you're saying you have the biggest angle and not the biggest side, which is fundamentally impossible. So, 21, it's obtuse. Is the side opposite that angle the biggest side? Yes, it is. 1 solution. Obtuse, there's only 2 possibilities. If you have obtuse, there's only 2 possibilities. Now, I'm going to keep using A and B just because that's what the originals were in. Just remember, A stands for the side opposite angle, and B, I'm writing this because they won't always be A and B in your problems. B stands for the other side. If it's obtuse and A is greater than B, 1 solution. If A is less than or even equal to B, no solution. If it's equal to B, then that means you have an isosceles triangle with 2 obtuse angles, and again, it's impossible. So that's why it can't be less than or even equal to B if it's an obtuse angle. And those are all the tests. That's everything that you need to use to figure out how many solutions you're going to have. Are there any questions about something we've written down before we start solving these triangles? I grant that. But I'll tell you this. Remember how we said the directions will tell you what to do? Whenever we test over this, the directions, please notice what they say. Oh, just kidding, wrong direction. Wow, that's supposed to be yesterday's homework. That's not even today. Well, look what they say. Two sides are given SSA. Pretty much every single problem we did yesterday using law of sines, they gave you two angles and a side. Every time. If you are given two sides and an angle and asked to solve the triangle, you know you're going to be having to do this test. So that's the kind of mental footnote you need to make. You're going to need this anytime they give you two sides and an angle and ask you to solve the triangle. That's when you know you'll have to use this. So we said 21 was one solution. Now we're just ready to solve. Now all the one solution problems are going to be pretty much exactly like yesterday. Only difference is we're going to have to use, we're going to be looking for angles instead of sides first. That's the only difference. So let's look at 19. Let's pick that one at random. 19. Now let's assume this triangle is ABC. So we're looking for angle C, side B, and angle B? Yeah. Those are the three pieces we're looking for, correct? Assuming it's an ABC triangle. I guess you could label that whatever you wanted to. Now, you're still using law of sines today. So, which side angle pair do I set up to start my proportion? A. Sine 63 over 10 equals sine of C over 8.9. We're just looking for an angle instead of a side. But all the math is going to work the exact same. You still cross multiply. You'll still divide by something. 8.9 times sine 63 equals 10 times sine C. You're going to divide by that 10. But then you haven't solved for C yet. You've solved for sine of C. How do we solve for C if it's linked to a sine? That's exactly what you do. You do sine inverse. So that's exactly what we're going to do. We're going to take, make sure I'm in degree mode, which I'm not. We're going to take sine inverse. And we're going to put that whole big thing in there. 8.9 times sine of 63. Now you may notice I use two sets of parentheses to open this. That's because one is for my entire thing, and then I need one to put my numerator together. So 8.9 sine of 63, close the numerator, divided by 10. Close off the entire fraction. Shabam. Angle C is 52. Oh, crikey, I don't remember what the direction says. Anybody open to this page in the book? Was it one or two decimal places for the angle? 10, so just one. So this would be 52.5 degrees. Angle C would be 52.5 degrees. And from here, it's a downhill trek. What's angle B? How do we find angle B? Yeah, just add the first two and subtract. 115.5, subtract. Was it 60? Did you add it to 60 or 63? Yeah, well, that's what's good. Okay. So, how are we going to finish this up? How do we find side B? Law of sines. Yay, law of sines. I knew we'd have it in unison. So, law of sines again. Use the same pieces you started with. Sine of 63 over 10 equals sine of angle B over side B. And from here, this is exactly what you did yesterday. So if you didn't have questions yesterday, then from here it should be a cakewalk. Cross multiply, divide, solve, find B. Questions about how we solve these one solution problems. You're going to have to start out looking for an angle, and then when you find it, you can find the third one by subtraction, and then you use law of sines one more time to find side B. Questions about the one solution problems? No. That's not the right answer, was it? The no solution problems are awesome. You have nothing to do. Just say no solution. So now we're down to the two solution problems. The two solution problems aren't really that much harder. They're really not. They just require one or two more steps. Let's pick one. 27. Two solutions. Now we already know it has two solutions. So all we need to find is angle B, angle C, and side C. But we have to find them twice for both possible triangles. So I'm going to call this set 1, and I'm going to call this set 2. Angle B, angle C, and side C. That goes back to the DOM, because one of them will be acute, and one of them will be obtuse for angle B. So, here we go, just like the last one. Sine of 37 over 12 equals sine of B over 16.1. Cross multiply. Divide by 12. And then take sine inverse of that whole fraction. I'll race you all on the calculator. Second. Sine. And if you get it before I do, just blurt it out and I can stop doing this. 16.1 sine 37 close divided by 12. Really? I'm faster with a mouse than you guys are with your thumb. 53.8 degrees. 53.8. So that's our first angle B. Now, before we finish the first triangle, we're going to go ahead and go over to the second set. I said earlier, and I forgot to tell you why those two angles were supplementary. Boy, I really am losing track of my slides here today. They're supplementary based on one simple fact. You see this two solution thing right here? If we just look at this little triangle right here, doesn't that have to be obtuse because these two things are the same exact side? I mean, not obtuse, I mean the isosceles. Therefore, these two angles are the same. Therefore, their linear pairs are going to be the same. So therefore, these two are going to be supplementary. That was the logic behind that. I talked about it earlier, but I didn't tell you why. So, we know they're supplementary. So, if the first one is 53.8, what's my other angle be? $126.2. So now you're going to solve both sets individually using their different angle B's. So if we add and subtract B and A to find angle C, what's angle C going to be? $89.2. What's this angle C going to be? 90? 16.8. All right, and then we'll find the two side C's by setting up two separate proportions. This one we'll use sine of 89.2 for side C, but this one will use sine 16.8 for side C. And you'll just solve them individually and be done with both possible solutions. I'll set those up. I don't guess I'll bother working them out completely, but so those will set up. For this one, sine of 37 over 12 equals sine 89.2 over C. And this one will set up sine 37 over 12, the exact same, except it'll be sine 16.8. 16.8 over C. And then you'll just cross multiply, solve for C, boom, boom, done. Only trick here to remember is that the first angle you find, so many people get this step confused. They think that these two are going to be supplementary. No. It's going to be just the first angle. Notice these two aren't, just these two. The first angle you find Its supplement will be the other angle of that label, whatever, B, C, whatever it turns out to be. That's the only pieces that are connected in those two triangles. Everything else will be completely independent. Questions about anything you see on the board right now? They're the same thing. They're both law of sine. The only difference is, yesterday we did this one where you were looking for a side, and today we did this one where you're looking for an angle. It's all about what you need to find. You plug in everything that you have. If you're given two sides and one angle, that's what you plug in. If you're given two angles and a side, that's what you plug in. But it's the same formula. Same formula. You mean, how do we know if we need to do the test? If you're given two angles, you won't need to, because you'll add and subtract, find the third one, and you'll go. If you're given two sides, you'll have to do the test. But all the ones today, you'll be given two sides. I didn't want to mix the two on the first step. Questions? All the two solution problems are going to work like that. Okay. Then, nice or mean? That's Friday. That should not be an excuse. Man, my wife's been telling me I need to be meaner. So torn. Don't listen to my wife. Are you suicidal, man? When you get married, I'm going to remind you that you said that. Fine. But you guys better be productive if we cut it right here today. Here we go. What? You do the same thing. Just use the obtuse angle and the law of sines. Yeah. Here we go.